Hello Basement Programmers, and welcome to the Basement Programmer YouTube channel. This is Tom with basementprogrammer.com. This video is part of my IoT for the .NET Developers series, in which we're looking at ways to develop an IoT-based solution using .NET. Now, in the last video in this series, I walked through how to get an IoT device, in this case, my Raspberry Pi, connected to the AWS IoT Core services. In this video, we're going to take things to the next level. So first, what we're going to do is add a virtual sensor to our application. And that virtual sensor is going to allow us to create water readings that represent the water in a well. It's our fictitious use case, and send that data back to the AWS IoT Core services. Now, getting water levels into the IoT system is great, but unless we can actually do something with the data, it's not really going to be that helpful. So we're also going to look at what we can do to incorporate functionality into the service side of things, using .NET, again, wherever possible. Now, of course, once you start using the AWS services, there's always a risk you're going to incur some charges. So if you're concerned about this, there's some good news. Send an email to .NET on AWS feedback@amazon.com. I'm going to put the email address down here, and you can get some credits to help cover the costs. Now, I do need to mention this is a one-time credit offer. So if you've already sent an email to this address and gotten credits for, say, another influencer, for example, you're not going to receive a second set of credits. Now, at this point, it's probably helpful for me to drop into a whiteboarding session so we can talk about exactly what we're trying to accomplish here. So let's do that now.
Okay, so I want to do a quick whiteboarding session on what we're going to try to accomplish in this segment of the tutorial, or how to build a IoT-based solution using .NET. So I'm going to start off with, I'm going to have these IoT devices that are transmitting data. And these are going to be transmitting over MQTT. Now we're going to use quality of service, QoS, 1. And quality of service 1 means at least once delivery. So for every message that gets transmitted out of the device, we're going to get an acknowledgement back. Now, for messages that we don't receive an acknowledgement back, it's going to automatically retransmit, and that's all handled automatically by MQTT. Now, each one of these devices is going to have a GPS sensor and a water level meter. And obviously, for the purposes of this demo, these are just being built as mock implementations. They're not real meters, but in a real-life scenario, you would have these as well. Now, for the data that's being transmitted, we're also going to include date time, so we can make sure the messages are ordered properly. We're going to have a device ID, so that we know which device the messages are attached to, and we're going to have a message number, which indicates obviously the order that the message is being transmitted. So if we're going to define a primary key for this data, it would really be the combination of these two, the device ID and the message number coming in. Let's see, GPS, so location, water level, date time, device ID, message ID. I think that's what we're looking at. We may find more as we go along and build out the solution. Now, the other half of this solution is up in the AWS services. The first service we're going to interact with is IoT Core. Now, IoT Core we've already started interacting with in the second video in this series, and it was a service that we were connecting to, and it was bouncing the messages back for us. So all it was doing was taking the messages, publishing them back. It was so the devices were then receiving them. IoT Core has another portion to it, though, that's called the rules engine. And that's what we're going to start using in this segment. So the messages that come in here are then going to be pushed down into the rules engine. The rules engine then allows us to do certain things based on the data, the message, and what we want to accomplish. Now, for our purposes, we're going to start off with a very simple rule that takes all the messages and pushes those into DynamoDB. This will allow us to keep track of what the latest message coming from the device is. And it would be great for use for, say, a dashboard if we wanted to have visibility into the current water level meters of all of our devices. Because, you know, back over here, we wouldn't have just one. We'd have lots of these devices in a certain area, say one for each aquifer. Or if we wanted redundancy, maybe we have two in each aquifer. Okay, so that's what we're going to try to accomplish in this session, and we're going to jump into the code now. All right, so here we are in my development environment, and what we're going to do, first thing I'm going to do is start Visual Studio Code. Now, this is going to try to connect into my Raspberry Pi. Okay, and it's connected in. So what I want to do first off is I'm going to grab the sample project that I have created and posted up here to my GitHub repository. So it's Basement Programmer and it's IoT samples. And we're specifically going to look today at the episode 3 code. And I've put together the basics of the project here. So let's do git clone okay, episode 3, and we've got our structure here. There's a solution file, useful if you're opening up in full Visual Studio, or if you're opening up in JetBrains Rider. And there's a project folder here. The next thing I want to do is I need to jump into my AWS account, and I'm going to go to the IoT Core service. Now, I need to be able to connect a device in. So the first thing I'm going to do here is I'm going to jump to this Connect One device. Go next. Register and secure your device. So I'm going to create a new, what's called a new thing. So I'm going to call it the .NET test thing. Once again, I'm going to skip these options. Next. Now I'm going to choose Linux, and I'm going to choose Node.js. It doesn't really matter because I'm not going to use the actual provided sample that gets downloaded here. But I am going to download the kit. The kit's got some functionality that I do need. It's going to include, for example, the certificates. And I'm going to go next. Continue. Okay, and if I go view my thing, I can actually see the thing that was created here. All right. I want to open up this package. Let's extract all. And I'm going to do a couple things. The certificate files here that are here, I want to copy those over to the device. Go copy, I'm going to drop them right in the certificates folder. You can see they all get copied down. The next thing I want to do is there's a policy. So I'm going to open up the policy with Notepad. And you can see it's a simple JSON document. Now, the document that gets created is designed to work with Java, Python, or JavaScript, because the download doesn't support .NET at the moment. So what I want to do is I'm going to change this policy to support .NET. And I'm going to do that fairly easy. Okay, let's have a quick look at what this policy does. So the first thing is a statement that allows the device to publish or subscribe, or publish or receive on specific topics. So by default, we enable the Java, the Python, and JavaScript topic. I've simply added .NET, so we'll be able to send and receive messages on a .NET topic. Okay. The next thing is subscribe. So once again, pretty much the exact same thing here. Topic, except it's a topic filter. And I'm going to add .NET, so we'll be able to transact messages on that .NET topic. So we can send, we can receive, and we can subscribe. And then there's the connect statement. So the connect is basically what you can call yourself. So SDK.NET is what we're allowing this device to connect as. So I'm going to copy this statement here and go back into the AWS console. And I'm going to go over to security. Now what I'm going to find is there's going to be a policy that was created. So .NET test thing.policy. And what I'm going to do is edit the active version, switch over, and I'm just going to replace the text. The text that's in there is going to be the same thing as the text that was downloaded. So I'm just going to replace it with this new text that says .NET. And I'm going to choose this option here, set the edited version as the active version of this policy, and then say Save New Version. So the policies are designed to have multiple versions so you can tell the differences and what's changed. The active version is the one that's appropriate. This allows you, if you make a mistake, to go back in time and set a previous version as active. All right, so here we go. We've got the policy. We can see a description of what's set up there. And we can see version 2 is set as active. Okay. So that's now updated our policy. The next thing we need to do is, if we look at the script that comes down, so we get a shell script open, and let's open this with Notepad once again. This has got a curl command that downloads the AWS root certificate, and we need that in order to set up our device. So we're going to copy this, and we're just going to go into navigate into the navigate into the certificates directory, and we're going to run that curl command. So that's going to download, and you can see here now we have this rootca.cr. So it's downloaded the Amazon root certificate that we need in order to make all of this work because of the certificate chain. Just do a refresh. You can see there rootca is is on the system. Okay, so let's jump to program. Program.cs, this is an updated version of the code that we worked on for episode 2, and it's designed to have a little bit more functionality. And obviously we're working inside of a .NET project. Visual Studio Code has asked us if we want to restore the packages. Let's hit yes there. That's going to download all the NuGet packages that are necessary. Now, there's a couple things we need to update right away. The IoT endpoint. Now, if I look here at settings, you can see each account has its own endpoint. Okay, so this will be unique for your specific account. So I want to copy that, and I want to replace the placeholder text here that says endpoint there. And I've got a thing name and a client ID. Okay, so the client ID comes back to this policy. Okay, let's close that because we don't need that anymore. If we look, we're doing client.connect with client ID. So client ID we need to replace, and that is going to be, if we look at the policy, what we can connect as. So we're going to connect as SDK-.net. This is going to be our client. And then we have a thing name. So the thing name, we're going to use .NET test thing. Okay. Okay, we've got the broker port, so 8883. We're going to leave that exactly the same, and then we have the topic. So once again, we've got topics that we defined in this policy. So we've got the policy, we have the topic SDK/test/.net, which is what we've still got here. So we're good. Now, something I've added in over the weekend is these sensors. So for the sensors, we've talked about this before in the intro to this video. We've got a GPS sensor and a water level sensor. So I've created a class, a mock GPS sensor, and all it's going to do is it's going to grab a random latitude and longitude and use those as the location and report those back when we get a call. And the mock water level sensor. So what this is going to do is it sets a maximum water level of about 30 meters and a minimum water level of 0. And it sets an adjustment amount of 10 millimeters of water. And then all it's going to do is every time we go and say get a water level reading, it's going to do a random adjustment somewhere between 0 and 10 millimeters off of the current value, either up or down. So that's all it's doing, and it will give us some variation in the data as it's going. I might work on this a little bit more at some point, so you may see that the code evolves. Okay, so we can come back here and in the main definition, you can see what it's going to do. We're loading the root CA certificate, so root CA cert. We're then going to try to grab, based on the thing name, so the thing name is .NET test thing, .NET test thing, .cert.pem, .cert.pem, and .private.key, .private.key. There we are. So what we're doing is we're grabbing all of the certificates and creating what we need for security in order for the device to be able to transmit and receive. So you shouldn't have to edit this code here unless your certificates have a different naming structure for some reason. We're then going to set up the MQTT client. This is very similar to the last episode. And then we're going to try to connect and subscribe. So we're still bouncing the messages back. We're going to send a message up. We're going to receive it on the same topic just so that we can see what's happening on the command line. Now here's the difference. What we're doing in the loop, so each pass, and we're doing this roughly every 5 seconds, we're going to grab the water level from the water level sensor. We're going to grab the location from the GPS sensor, and then we're going to create this new water level message. So the water level message is set up here in the models. And you can see we're storing the sensor ID, we're storing the message ID, we're storing the reading date and time, and the GPS location and the water level. Okay, and that's going to be the message that we're going to transmit from the device up through to the IoT Core service. And like I said, we're going to do that roughly every 5 seconds. We're going to serialize this using the JSON conversion object to serialize it, and then we're going to publish it out. And then we're simply going to say we've published it, so we can see that. Sleep for 5 seconds, and then do the same thing over again. Now, down here we've got the same logic as the last episode, where anything that we receive, which is going to be every message we publish because we've subscribed to the same topic, we're simply going to write that down in the console. Now, there's one more thing that we have to do in order to make sure that this all works. If we go here to the IoT sample project, the proj file, you can see I've got a block that's commented out for you. This defines a file group. Now, what we need to do is for each one of these certificates here, so .NET testing, cert PEM, private key, and the root key, we need to add those items here. We need three. Oops. Testing dot cert.pem. And that's going to be root -ca dot crt. Okay, we need to make sure all of these items are here. And what this is going to do is it's going to copy all of those certificates into the build directory so they're available. This just stops us from having to do some weird navigation with parent directories and things of that nature. So, if you are using, say, Visual Studio or JetBrains Rider, you'd be able to just right-click on these and say copy to the output directory. But using Visual Studio, we're just Visual Studio Code. We're just going to do that here. All right, now with a little bit of luck, back in the directory with the CS proj file, I should be able to do .NET build. And we'll see if my code compiles correctly. Okay, we've compiled correctly, 0 warnings, 0 errors. So the next thing to do is, let's cross our fingers and go .NET. Oops, okay, we've got a problem here. Thing name.cert.pem. Okay, it doesn't like that. Doesn't like that, the way that code works. So let's we're just going to copy this here for the moment just to make that work. Okay, and we can see now with that little code changed, I have to look at why that wasn't working correctly. We're now getting messages sent through, and the messages are showing up as a JSON payload. So sensor ID, message ID, and you can see the message IDs are increasing here. The reading dates, the locations, etc. So we've got real, albeit mocked, but real data going through the solution. Now the next step is we're going to look at the service side and see how we can get that data pushed into another location. So we're going to take it, and in this case we're going to push it into DynamoDB in order to make that more useful. All right, we'll see you in the next segment. Okay, so here we are back at the desktop, and the next thing we want to do is process these messages as they're coming in through the IoT Core system and have them put someplace where we can actually do something with them. Now, an ideal first step will be, or a first location will be DynamoDB, mainly because we're transacting data that's coming through as a JSON payload. It's structured as a document, and DynamoDB is really good for that sort of data. It's also very easy to set up and use. So we're going to use that as our first stop. Now, I do have a sample message here that's come through, and this is just one of the messages I've run through in testing, and we're going to use that for a little bit of reference going through. Okay, so I'm going to jump here into the AWS console, and the first thing I want to do is I want to go over to DynamoDB, and I want to create a table. Okay, so the table is going to be the destination we're using. So I'm going to put IoT Data as the entry. For the partition key, we're going to think about what we want to record here. What is the message primary value going to be? So what I want is, we'll call this message. Message ID. And so the sort key is going to be how we're going to organize the data. So we can organize it. We've got a timestamp, so we'll put this here as reading time. Okay. Now I just want to I'm going to jot these down and copy them over into my Scratchpad area here. Message ID and reading time. Put those there. Now we've got some other options here for table settings. So we can either go default settings or customize the settings. I'm just going to leave all the defaults here for now. These are pretty well established for getting started out. Obviously, we would then look to tune these settings a little bit further down the track if that became necessary. All right, so I'm going to say create table. And that's going to take a few seconds to create. All right, my table is active now. So the next thing I want to do, I'm going to jump back over to the IoT Core service. Oh, got the message there. So I want to go back to IoT Core. This is back where I set up the device in the earlier part of this video. Now I want to go over here to the Manage section, and I want to look at message routing. And I want to go to rules. So IoT has this concept of a rules engine, and what that does is it enables you to create basic rules that function on the data as it comes in and then take some actions. So what I'm going to do is I want to create a rule. Give it a name, so we'll just call it IoT, .NET IoT Data. Doesn't really matter what you want to call it. Store all incoming in DynamoDB. And next. So the next thing I do is I get a basic SQL statement that I can execute on the messages that's coming in. So what I can do there is I might want to select out data elements. I might want to rename them potentially. So what I do here is I am going to say select, and this is why I have the copy of the message over here. I'm going to do a select with all the tags that I want to receive. So I want to get sensor ID, I want to get message ID, I want to get the reading date, get the GPS location, and I want to get the water level. Okay, so there we go. We've got that. Clean that up. And now you want to say from, and now what's the topic? So I want to specify the topic that all the messages are being transacted on. So I'm going to jump back to my source code, and I want to copy the topic here. This is one of the reasons why it's really not a good idea to send your messages and subscribe to the same topic. Okay, so I'm going to copy that, and I'm going to jump back here, and so my topic filter now you have the ability to add a where clause, so these rules can get very specific. I might have a rule here like I'm building where I want it to fire on every rule or every piece of data. I might also have some rules that maybe fire in exceptional situations. So like maybe where water level is particularly low, for example. I'm not going to use that functionality here. I'm just going to say select all that data from every message that comes through on sdktest.net. Okay, next thing I'm going to do, I'm going to hit next. So there's my SQL statement. And now I have the ability to add rule actions. So think of this like when the message comes in, I'm going to grab this data and then I'm going to do this thing. You can see here there's actually a fairly good set of built-in actions that you might want to be able to do. So for example, DynamoDB is what we're going to use. It means I don't have to write code to do it. Now, if there isn't a destination that matches what you want to do, obviously you've got Lambda. With Lambda, you can do pretty much anything you want to. So here we go. Kinesis Stream is another one that is potentially useful. So, and we might look at that a little bit later in the series. But for now, I'm going to choose DynamoDB. Now, there's two options here, DynamoDB and DynamoDB v2. Obviously, the DynamoDB v2 has a little bit of extra functionality in that you can split messages, etc. But for our purposes, where we're just injecting the data directly into DynamoDB, the first option here is fine. So I'm going to choose DynamoDB. And then I get a little editor panel here. So I get a drop down for table name. So this is the table that I want to interact with. And now I need to specify some bits of data here. So partition key, this is message ID. That was the partition key that we defined when we created that table. So there we go. And sort key, there we go. So, oops. Okay, so partition key is message ID, partition key type is string, sort key is reading time, key type is string again. So now what we have to do is figure out the value, the data that we want to use as these particular values. So what I would really like to do is have my partition key, so my message ID, be a combination of two fields that come in, the sensor ID and what it thinks the message ID is. Okay, so and that's important because I can't just use the message ID, because I may have 1,000 devices out in the field and they all think they're transmitting message number 35 in this case. So I need to make that key unique so that I don't really lose data. Okay, so what I'm going to do here is I'm going to use some substitution values. I'm going to say grab sensor ID from the message. So you can see there, dollar open curly brace, sensor ID, close curly brace, dash, dollar open curly brace, message ID. Okay, so that's going to make a composite partition key or primary value that is the sensor ID, a dash, and then the message ID. Sort key value, like we said, is reading time. So what I'm going to do here is dollar open brace, close brace, and then reading date. This is the value that I want to insert there. Okay, write message data into this column. We don't need anything to do there. We're just going to leave that blank. Operation. We're going to leave this blank. It's going to do an insert. And really what it would do is, based on the primary key, it would either do an insert or an update to the record. So if, for example, I had left off sensor or message ID and I just had sensor, every time the data comes in, it would overwrite. So what I would have is just the last message. And that may be useful for something like a dashboard. Okay, but I'm just going to leave that blank. And now we have IAM role. So everything that interacts in AWS obviously needs some permissions. So what we need is a role that we can give to the IoT rules engine that's going to allow it to do the actions it needs to do. So I don't have, well, I have lots of roles in my account, but I don't have one specific to this task. So I'm going to go create a new role. I'm going to give it a name. So .NET IoT to Dynamo. I'm going to go create, and it's going to go and it's going to create that role for you with all the necessary permissions. We don't have to do anything there. And then we have an error action. So you can use, well, okay, first off, we have add another action. So we can continually add more and more actions to this. So if we wanted to add something after we insert it into Dynamo, and we might consider doing that later, and an error action. So it's an optional, if something blows up, do this instead. We're not going to need those right now. Okay, so we'll go next, and we've obviously got a a review panel here so we can look, see exactly what we're doing, and go create. And with a little bit of luck, there we go. The rule is in place. We don't actually have to do anything else for this to start working now. Okay, so let's jump back into our code. So we've got the code exactly as it was before. We haven't changed anything. So what I should be able to do is come down here to the console and do .NET run. As always, it's going to go through, it's going to build, and it's going to start publishing messages. So you can see that we've got message 0. 5 seconds later, we'll get message 1. Give it another 5 seconds. 2. Okay, I'm going to leave that running, and we're going to jump back once again to the AWS console, and let's have a look over here at DynamoDB. Click New tab. Get back. We'll go Tables, Table Data, and we're going to go Explore Table Items. We can see here are our items coming in. So this has got all the messages that are coming in. And there we go. So we now have a working solution where we've got an IoT device running .NET, transmitting values up into IoT Core, and depositing those into DynamoDB. And well, on the service side, we haven't had to actually write any code. We've just got .NET down there on the device, and continuing on. So I'm gonna break this video and get this published so you can see how to get this far, and then we will come back with another video and taking things a little bit further. Complete source code for all of my videos can be found on GitHub. You can find me there at github.com/basementprogrammer. Thanks for watching my video. If you found this video helpful, please hit the subscribe button. It helps you to know when I have new content out, and it helps me to know I'm creating useful content for you. You can always find me at basementprogrammer.com, on Twitter, and the Basement Programmer podcast. Details listed here. If you have any comments on this video, or you just want to get in touch, you can always email me. The address is tom@basementprogrammer.com. And I'll see you next time.